Hi guys, this is another half of another video, something I promised you. This is the other half of the Genesis video. What we have here is the box that lives under the driver's seat of an ambulance. This is in charge of all of the high current switching. As you can see, we're not talking about small amounts of current here. It appears that if you're going to rock quite a bit, which is, be too careful of that. This is responsible for switching the battery, controlling various things. We've got the siren amp under here. We've got a fuse board on the front. Oh, yes, it is suitably grim. And then all our connections off to the vehicle. So we'll have a quick look at this. I've got to tear this down anyway because I've got use for various bits for it. It's much easier to put this into service in other ways. If it's all disassembled and I don't have to then say, oh crap, I need such and such, I've got to go quickly tear that off of this. But it also means I can have a quick look at what's in here, show you guys how this all goes together. I am going to leave you zoomed out at about that level, quite simply because I've got quite a restricted workspace. So you've got the boxes down here and then the camera is literally here. So that's about that much distance. Also using the new setup again, so hopefully I can keep things in shot. Let's dig in. So this is off of a fairly run-of-the-mill ambulance setup. This is from a old West Midlands vehicle. This is set up for 3 batteries. So you would have a comms battery, a mains battery and a chassis battery. Comms battery is for your Terrafix, which is the navigation and control systems fitted to these vehicles. The radio, things like CCTV and things like that. You have a main battery which runs the vehicle itself, and then you have an auxiliary battery which is all your emergency lights, the stretcher winch, the tail lift and things like that. The idea is to segregate these systems a little bit just so that one can't necessarily kill the other. We do a lot of switching in here, so you can see the top here. We'll pull these out in a minute. 2 very, very large solenoids which are designed for cross connection. So one of the ideas behind this is, say, if for instance you run down the main vehicle battery, you hit a button on the Genesis system, or with a lot of slightly older vehicles or more robust setups, it's generally a physical switch, and that will connect your comms battery or your auxiliary battery to the vehicle battery. You can get the engine started and get things running. A lot of this is put together with connections and things you should be familiar with. There's nothing magical or special in here, and you'll recognise a lot of the connectors. I will grab one from over here because it's easy to see. So we have quite extensive use of Anderson connectors. I can't remember exactly what these are called. Just Anderson connectors, and the Anderson power poles as well. Are you going to focus on that? The idea is this was supposed to be modular. You can mostly remove this without having to cut any wiring. The only real flaw in the plan is the siren amplifier's power connectors. But yeah, the wiring for the siren amp is not connected, so that had to be removed. How are we looking now? Come on. That's going to get really old really quickly. Right, so we've got our Anderson connectors on the back here. So we've got one here for the power supply to the Genesis system, which you've seen. We have a main earth, and then underneath, what do we have? We have the auxiliary battery and the chassis battery on another one under here. Let's just pull these apart. So these Anderson connectors are just bolted together. There's nothing special going on here. Generally these are designed to be bolted to a chassis. Let me just find a tub. There we go, because none of this will be used again. Yeah, these Anderson connectors are designed to bolt down to a chassis or bolt to a handle. In this case, just to keep everything together, I'm guessing they've bolted them to each other. one's going to move. So yeah, I'd say the idea is to keep this all modular. In theory, you could swap this box out fairly quickly with another one for another vehicle, and then you could take this back in, work on it and solve the issues on it. Reality, you're not going to have a lot of problems with here. You've got a handful of relays which are easily swapped out. There are some bridge rectifiers down there. I will explain why they're in there in a minute. And you've got the big solenoids here. I might have to switch camera software if this continues dimming like that. I know Big Clive does use this and swears by it, but if it's going to continue messing around on me, then we might have to go back to good old Huawei stuff, because at least we know it works. So the quest to get a permanent camera for this still continues, but for now I actually have a monitor attached to my phone so I can see what's going on. This is the old phone that was slightly dead. We can just buzz those out. He says. That's now an X screw. All of these are quite clearly labelled as well. The Anderson connectors, the colour code is more than just a colour code. You cannot actually, for example, you've got this red and this yellow one here, they cannot be plugged into each other. So there is an element of safety here, and that's why you'll see that all of these on here, with the exception of that one and that one, are different colours. Come out. See, I've brought bare minimum of tools over here, and I can see me regretting that fairly quickly. There we go, just separate those out just so we can see what's going on a bit better. That one's the same. Someone's pre-shredded the head on that. These do get changed, they do get pulled around and bits modified as things change. Not as much now, but there were quite a lot of vehicles around at the point that the ambulance service changed from VHF to a system called Airwave or Tetra, and that required a certain amount of modification to the comm systems and things like that. Most of the ones that are coming out of service now predate this, and they're built with the appropriate radio systems in mind. I'm just going to pop this air stud out. This may require something else, bear with me. So let's just grab one of those. What do we reckon that is? It's a 13. It's always either a 13 or a 10, except for those solenoids, which definitely aren't either. There we go, that's off. So let me just zoom you down. Right, so just kind of a quick look at these, because we'll pull these out easy enough. These labels, I was trying to get these labels to show up better on the screen, and they are actually quite worn out. Pay attention to the screen rather than the real thing. That picture looks a bit grainy as well. Hopefully it's not too bad. Can we have a bit more light? There we go. So apologies, I'm learning on this as well. So we've got a bunch of relays here: horn ring, run lock, comms ignition, and then that one is labelled, but I can't read the label, and something else. Back again. Sorry, phone went. So we've got horn ring, run lock, comms ignition. I think this is comms ignition slave, which I'll explain. No idea what this is. So horn ring, we'll pull that out because we can take these out as we're going. Focus. Yeah, that is a bit fierce. I'm going to have to mess with my lighting a bit more. So horn ring is fairly simple. What this does is, if you heard a vehicle on running its sirens, you'd have noticed quite often you'll hear the vehicle horn beep as well. What this is when you turn the siren on, the siren comes in and standby, and then we use a relay driven from the horn circuit to control the siren. The first beep will turn the siren on. Every other beep then will change the siren pattern. Again, if you've heard a vehicle, emergency service vehicle running on sirens, you'll have noticed every time the siren changes tone, you'll hear the horn. And then with most of them, it's a double tap and that turns the siren off. And it means that you don't have to use your hands to mess with things. Run lock. This is quite often on, especially on cars and vans rather than ambulances, a separate module. And the idea with run lock, the run lock system is this is installed. If we can get him out. Again, standard relay. The run lock is installed across the ignition feeds from the ignition switch. In the case of the Genesis system and most of the embedded systems, it also connects into the brake lights, the gear selector and things like that. And the idea is you can get to your emergency, turn on the run lock, take the key out, leave the vehicle, and the vehicle's engine and power systems will continue running. It's mainly designed for situations where you are going to be on site for a while and you're going to need to leave things running so you don't run your batteries flat. Say a road traffic accident at night where you're going to need to leave your lights running, you're going to need to use your spotlights, your scene lights, things like that, and obviously your battery is a finite resource, so run lock allows you to leave the engine running. Comms ignition, that's going to be an ignition feed to the comms system. I can't see what this is. The other thing with run lock is run lock monitors the handbrake, the gear selector and that, and if you touch any of that or touch any of the pedals, certainly on the Mondeo that we used to have, it will shut the engine down, so you can't just jump in and drive off. Ignition slave, often called it escapes me now, there's another name that Volkswagen Audi Group used for this as do others. Load relief relay. So this is to provide a switched ignition feed to a number of circuits without actually placing any load on the vehicle's ignition feed. Then we have this one. Again, standard relay, no idea what it is. Let's zoom you back out. So, our relays are out. I'm just going to quickly buzz those relay holders out. So everything in here is coming out. I don't have any wire cutters with me, so you might regret that. These are fitted in with riv nuts. If you've never come across riv nuts before, they are amazing little things. They go in holes much the same way that rivets do and compress. However, where rivets tends to leave a hole, riv nuts, can I even get onto that one? Riv nuts leave you with basically a threaded tube. I'll take you in closer to look at those, and you can pop screws and things into them. This, I suspect, the run lock one was a later addition, or looking at it, it might simply be that there's no way of easily getting the riv nuts in here. I could go and get a drill and just quickly spin those pop rivets that hold this cross piece in out. I don't know that that's really worth much. Well, that must have gone in first. Okay. So that's our relays out of the way. Not much we can do here. So we've got this connector here, which I believe was the space heater. So a lot of ambulances have a diesel space heater fitted to keep the rear and the cab warm with the engine not running. That's what I believe that one was. We have this here, which is comms power. So this would have gone off to a panel. I do actually have the panel. This went off to a panel in the rear of the vehicle, hidden away in a cupboard, and that contained the radio, the CCTV systems and everything. These power pole connectors are actually quite good. Bear with me a second. Yeah, these power pole connectors are good. They are quite modular. I should have brought some cutters over. So obviously you can mess these around, they just slide onto each other like that, and you've got a reasonable amount of flexibility as to how they mate, so we can mount them top and bottom there. If I grab the other side of that connector, I'll do that. So we now have two versions of this connector that are no longer compatible, and it obviously means that you can make up all sorts of versions of this so that they can't be plugged into each other. So that's how it was. You can, and you need to be aware of it if you're using these, manage to do that, which is obviously not a good thing, and you can make up, oh dear, various versions of that. So again, rather than have them on top of each other, you can have them polarized like that, and you can add multiple ones. So we could, for instance, slide those on there, and we've got a four-way connector all of a sudden. They are completely modular, they're wonderful things, and they're really good quality as well, which is why they're used in places like this. So we've got here, these would have been connections to and from the Genesis system, from the switched outputs and from monitoring. We've got a random, so one of our relays there was for switching something to do with that. It's difficult without the circuit diagram to know what's going on with these. I am just going to go get a screw, drill bit, and I think we'll pop these rivets off. No hammer. 1, 2. Whoa, holy whiteout Batman. Don't worry, I won't be long. There we go, and we can just pop this off and out of the way. We've got two fuses here. These fuses are, they're actually this comm supply here. So what I'll do is we'll pop those fuses out. Can I just, nope, I'm going to need something bigger than that for those. So we'll just, oh dear, all being well, these fuses have probably not been removed for about, what was it? It was an 07, so 13 years these fuses may have been in there. Oh, there we go. Nice heavy 50 amps, both poles fused. It's generally the case with comms equipment. And let's just spin those off. None of this is going to go back onto new vehicles. There is a possibility that some may be used for repairs in the event that we are stuck for a part. There's something we can't get hold of, something that's become obsolete, or something that is restricted to just these. There shouldn't be anything that's unique to these, but there is. We're going to need a flat head screwdriver. I can't get that screw out now. There we go. I'm slightly restricted on space, which is annoying because I'm in the middle of setting up another video here. There we go. So we'll pop these off. The idea, especially when breaking down something like this, where there are a lot of useful parts, is to try and preserve what you can. So, you know, a lot of people's response at this point would be to just slice the all the wiring. There's there's a lot very heavy duty wiring here, including what I'm working on here. Heavy duty wiring of any quality is expensive, so it's worth preserving when you can. We build our own trucks for our own use. Both of our vans are quite specialised. Sorry, I'm off screen. Both vans are quite specialised and have quite a lot of electrical equipment on them, and we can reuse some of these jump wires when we're doing builds like that on our stuff. And again, they can fail, they can get damaged. The usual thing on these that fails as a result of end user problems is actually the fuse boxes on the front, which I've not got to yet, but those are directly behind the driver's ankles, and it's not uncommon that things get kicked out, fuses get bent and generally destroyed. Right, those fuse holders are out. This is very, very glary. I don't know that I can do much about that. That's a little better. The trouble is we start going into the territory where things start getting grainy. Right, I pulled this stud off here, so let's just work our way through and pull everything off of this. Got a lovely bundle of cables there. Obviously, oh sorry, with equipment like this, it does come down to the fact that ultimately someone's life could depend on how well built this is, and you can see a lot of this. This is the earth cables to everything that's being switched, to the relays and things like that. As you can see, every one has its own feed. There's no commoning up here. You'd be able to trace this all the way back to these relays and things like that. So you should be able now to pull that out. Let's just cut that wire there. So that's the comms feed out and its fuses. Now our earth to the comms feed went straight onto the earth tab down here, and our power actually comes straight off of the comms battery. So down here is a very, very heavy duty fuse. You'll see that when we get there. And that comes straight off the comms battery. So the 300 amp fuse down there, oh, mind my head. Yep, 300 amp fuse down there is for jump starting and battery cross connection. So that's actually what supplies the comms there via the 50 amp fuse. These two here, battery 1 charger, charger earth, battery 2 charger and battery 3. Most ambulances and emergency services vehicles can plug into what's called a shoreline, and this allows them to permanently charge. In this case, I have the unit. Oh, big heavy battery charger, and it's going to white everything out. This provides, I can't remember off the top of my head, it's something ridiculous, 50 amp battery charger. So, seeing these in action, we did a shoreline for a customer of ours, Sharps Fire. They had a faulty charger or faulty shoreline on one of their vehicles. The vehicle had gone flat while it was in storage, and we solved the problem, let the Xantrex start up, and we're talking about a large man fire appliance here. That charger had put enough power in the battery in 5 minutes to start that vehicle. They're fairly major. They can't quite jump start the vehicle, but they're close. And this means that all the time that the vehicle is stood up and these are plugged in, everything is charging, everything is ready to rock and roll. Right, where should we go now? I'd like to get that off, which is the siren, but I don't see any sane way of doing that. I think if we undo those screws, oh come on. So everything else has been a crosshead screw, except apparently that. What was it? I reckon that's a 3mm. Ah, can't get it out. It is indeed. I don't think this will help us. So unless someone has been nice enough not to put the bottom screws in tight, which they haven't, we're getting nowhere on that. And that was the sound of all my screws going on the floor. Can we maybe move this? No. Okay, that is apparently the last thing that's coming out. So where should we go now? We've got fuses on the back here. Maybe we should spin those out. Just going to put stuff back in here so it's ready for me to use. One of them, and what size do we reckon those are? 5.5s? Nope. 6? Nope. Of course it wouldn't be a 6. 8? Oh, great. So yeah, that's one of those. It's not anything that we've got to hand. Why would you give a 5.5, 6 and a... Is that an 8? I don't think that's an 8. It's an 8. Okay. I bet you I didn't bring over anything else that would get that. Let's try that. No. It's definitely not going to be that. No. Okay, spanner it is. So, I'm not sure what these fuses are, we'll look at them in a second. What I want to do is try and strip the sides down and work our way down into this. So these are maxi blade, not maxi blades, just maxi fuses. Like the Anderson connectors, these do all clip together, so you can make sort of a distribution board up just by clipping them all together. Some cars you'll find these in, some cars don't use these in favour of the maxi blades, which are these. Generally these are the ones you'll find either on the battery terminal or around the engine fuse box. These are very high current devices. I think all of the ones that I'm removing here are actually the fuses for the chargers. The vehicle that this came off of unfortunately sustained fire damage. It was either light clusters failed, which is not uncommon in the Renaults, or potentially even an oxygen fire, which is just not nice at all. Nothing there is moving. No, this isn't going very well, is it? Can I get some pressure on that to push it through? No. There are screws in there, so they're going to need to be driven off. Right, okay. This is not necessarily going as well as I hoped. So let's just clear some space down here. Get down to these rectifiers. A lot of you are probably wondering why, on a system that is running on DC, have we got lots of bridge rectifiers down here on the side? 1, 2, 3. Oh, there's 4. Truth is, you see this one here only has 2 connections on. They are used quite frequently because you've got 2 forward-facing positive diodes. They're an easy to use package that can bolt up to aluminium, and quite often they're used for combining multiple signals. So a good place to use these would be on the back of the headlights. It's not necessarily a good place to use it because you get voltage drop. But however, what you'd normally have is you'd have the positive output terminal of the bridge rectifier connected to the bulb itself, and then you'd have a feed from the vehicle wiring and a feed from the headlight flasher. The idea being then is the headlight flasher cannot then backfeed into the vehicle wiring, which can have cause some issues with vehicles with ECUs. It would also potentially result in things like dashboard warning lights and things coming on, and you'd be backfeeding the other headlight as well, so you would only be able to flash the headlights on and off. Now most headlight flashers alternate, which means that you'd just turn the headlights on, you wouldn't flash them. So the diode in here prevents backfeeding, and they're also occasionally used, as this one has been, just for the sake of using it as a large heatsink diode. They are available in better packets. You've got low drop Schottky diodes available now as well, so it's not really something you necessarily need to worry about so much anymore. I've just noticed these relays are also modular. A lot of automotive stuff like this is, so you can bolt those together as well. Right, we need to try and get somewhere here. Where shall we go now? I think we'll spin this round and drop everything on the floor. Let's just pull these two out. This is another fuse block down here. What they've done, looking at this, they haven't done it on this one, is actually they've got threads in the aluminium plate, and then they've put the bolt on to lock it, which means they ain't going to push out. They need to be screwed out. That one, however, feels like it probably is spinning, so we'll ignore that one for now. Find out where in God's name I put my crosshead screwdriver. This is definitely turning into one of those videos. It's not helped by the fact that I had to turn the lights down slightly to stop the whiteout. There we go, we've got more rib nuts in there. I will grab a rib nut in a minute and show you how they work, because they're amazing little bits of kit. So what I'm doing here is releasing the two fuse blocks. These should just pull straight back and out. There we go. Anyone that's worked on vehicles will recognise those. And you can see already, have I got a pointy stick? Not really. We've got one here bent up. These are directly behind the driver's heels, so they do get kicked quite a lot. I am going to pull all the fuses out, mainly because I have a separate place for these to live. Yes, I know. You've got another bent one there. Yeah, generally as the driver puts their heels back, they do start with perspex covers on, but to be honest, I've never seen one that's still got the cover on. And if you're driving an ambulance and something suddenly dies just after you jump in the seat, look down and see if these fuses are there and check them, because quite likely you've kicked a fuse out. These are just spade terminals on the back, so we will pull those out and then we can get these out of the way. Always pull on the connector. There you go. So you've got eight blade fuses, and then on the back you've got spade terminals to go onto. They can go in the wiring box. Yeah, never ever pull on the wires on these. We'll never pull on the wires for a connector anyway, but not so much with these silver crimps that have been used on here, because they'll have been put on properly. But certainly if someone's been in with the blue crimps, we use the blue crimps, we've got the right tool for them, the tool is properly set up, and we know they crimp properly, we know which way around to crimp. But a lot of people do use them on DIY jobs that use the really thin metal things rather than the proper crimps, and they don't necessarily always crimp properly. And quite often going through and doing what I've just done there and pulling on the wires, you'll just rip things to pieces. Let's just cut some more cable ties. So here are your cross connect solenoids. These are basically ginormous relays, and these allow us to cross connect the batteries. These are used in some situations to isolate the batteries. Not in this case. Oh, these pull off, that's handy. Let the other one go. Someone noticed that this was going to be a problem before, and they've actually sliced the bottom of those out. Yeah, sometimes these will be used for isolation. In this case, they are being used to cross connect the batteries, so it looks like we can cross connect the engine quite likely to the comms and the auxiliary battery. So I guess you get 2 chances to kill the battery. I think looking at this, it's going to be easiest to just take all of these off. And if I were doing this on an actual vehicle, this would be a socket, and these would be torqued to a specific value. The value is normally given by the solenoid manufacturers. This is something that follows all the way through to the battery. The large AGM batteries that tend to be used, sorry, I'm making you wobble. The large AGM batteries that are used for the comms batteries and for the auxiliary batteries, they even have specified torques for the terminals on them. The idea is that it should be possible for nothing to rattle loose and everything should make a good connection. But a lot of this stuff is brass, so there comes a point where if you just continue tightening it up, you're going to have a problem. So the idea of using a specified torque on these things is to get a good happy medium between a good connection, a secure connection that's going to stay where it should do. Oh. And not ripping the terminal off, or even worse, spinning the terminal in the battery, which I've seen done. Right, we'll retrieve that one when we get down there then. So we've got our cross connect wires here. So obviously this is acting as a common. I would imagine that's the chassis battery. You'll see there's a couple of small terminals fallen away as well. They will be part of the Genesis system, so it can detect and monitor the battery. So this is a good example here. You've got 2 wires. You've got a heavy battery which goes off to a load, and then this is almost certain a monitor wire for the Genesis system. This here will be all our positive connections down to our fuse box. Right, can we get in there enough to get those solenoids off? I think we might need a little bit more length. Can we get them? No. So I guess the simple answer to that is stop using the windy gun. And go back to the old-fashioned way of doing it. That's what fell on the floor, I was wondering. We should be able to get in here with a screwdriver, I'd have thought. There we go, there's one. The actuation terminals for the actual coil are further down, I can see them. Any of you that have worked on mopeds or motorcycles or even lawn tractors, these will be familiar. They are pretty much the same thing as the starter solenoids on them. That one's going to be tricky to get. Where is it? There we go. really don't envy the people that had to assemble this, because it is all absolutely shoehorned in here. And I'm guessing, I'm trying to work out in my mind how you would do this, and whether it would be something that you would wire in situ, or you'd put all the fittings in and then you'd put a harness in, or what. And everything is dependent on everything else. There's obviously a right and a wrong way to do this. There's your solenoid. So 12 volt, open, normally open. We don't have any indication as to what the maximum load is on there. We've got SU280, so 280 amps maybe. Who knows? You've got positive mark there as well. I'm not sure that that's overly important for these things. There won't be any protection diode in that. Big wiring box. Let's see if we can get the other one. Because if we don't get some of this big wiring out, we ain't going to be getting anywhere. Come on. Where is it? Just so much wire. It's why I wonder how these all actually get put together. Because there we go. I'm not actually sure how I would do it. If it came apart completely, so if we could repeat what we've done already on the front to the other side, so I guess you just lay it out like a flower and then screw it back together. I mean, even if you could just take the back off, that would be helpful, but this is just absolutely crammed in here. I suppose with the high current stuff, it's maybe not so much of a problem. There's another one. We've got a nut down there that we want. Or have we got two? I can't find two. There's one. I'll put that one aside before we finger in the box. Right, so I think we're making progress. So these are all the fuses. So what have we got in here? So yeah, battery 3, battery 2, battery 1, ramp power and ignition slave, and possibly an empty one at the bottom. Ignition slave is what I said, where basically it's there to take the load off the ignition key for lots of sort of small loads and things like that. So obviously in a normal car you'd have things like your car stereo would come in the accessory position and things like that, and this is all really aimed at taking the load off of those circuits. So what we're going to do is spin that off, because you can't actually get to that screw under there. And you should then be able to pull the fuse out. There we go. And you see, that's not a good sign. That is actually, was it welded? I don't know. We've still got this crosshead on there. I'm not going for an hour-long video, but I can see this getting there. Yes, I'm being impatient, I know. So these just push down and the tops come off. There we go, and we're going to have to rattle through all of those terminals and pull them off. Bottom one is unlabelled. I also noticed it doesn't have a fuse, but it does have a supply, so that's obviously a spare of some kind. And of course we've got all these lovely, lovely, lovely things in our way now. I don't think I'm going to get all the way down on these. Okay, they're just going to fall in the bottom, and they can carry on falling in the bottom, to be honest. Not going to get that one. I'll just empty everything out once we're done. Can I get on that last one? Yes. Just put it down to one side here. Right, so all our wiring should now come off. I don't want to pull the fuse caps off, which would obviously make life easier, but it also, they are designed to be tethered and I'd like to keep them that way. Pull some fuses out. We've got 50s in those. What are these? They are I'm not coming out. There you go. Oh, they're 60s. Focus. No, it's just too washed out. Where did that go? There. So we've got one down here somewhere. There. Yeah, they threaded the aluminium and then lock nutted on the back. Just belt and braces really. Certainly when your supplies, I mean we've got 4 fuses down here which are the supplies, and the smallest one of them is 200 amps, so the last thing you want is any wiring that's on the 200 amp side of that fuse just flapping about in the breeze. The fuse will blow, but I'm not sure that all of this wiring would actually carry 200 amp, so we want to be doubly sure that nothing comes off. And you can see that we've got some movement here. There's another one in there. Oh, you can get to them with fuses in, okay. We've got 2 more, so there's one on this side somewhere. There he is. And now, thanks to the file of fuse covers, I can't get to it. Oh! I'll be out dark next time. Done that thing where it's got the very, very last thread and I can't quite get there. There we go. Yeah. Right, okay, then this is going to be a fun one because there's just so much stuff down here now. We are right on the very bottom. It's actually starting to look like we're getting somewhere in here as well. No, where's the screw head? It's going to be this one that you can't get to, isn't it? What's happening is we're actually catching the side. There we go. I think. That felt positive. Felt positive, get it? Felt positive, yeah? No, okay. I won't give up the day job. Okay, I think that's just split the video. I hope that's still recording because I'll be upset if it hasn't. Coming out. Ah, we're out. Right, okay. What we caught on, it's just things wrapped around in the fuse holders. There we go. So put that to one side because there's a metric ton of stuff down there that we're going to want. So we've got more stuff out there. We've got another one here, unfortunately. Let's see if we can get that one. It'd be a lot easier if I could get this damn siren amp out. Ah yes, this is the one that was just spinning. We need just hold that on. So I'm curious if any of you know how these are put together. If any of you have worked for UV Modular or any of the various providers that do put these together. I'm curious to know how you put these boxes together, because I really am struggling to work out how you do it. And it's not that this is the most flexible wire in the world either. Right, that one looks like they've actually drilled that rather than threaded it. Yes, okay. So that one's out. Let's just buzz that off. Managed to keep the nuts this time. I think that one's been changed before as well. What was that? ECU bus bar. Yeah, quite possible. So you can probably see those enormous fuses down here now. So I'm trying to work out which way we'll do this now, because I'm not sure that you want to watch me pull the whole damn thing to bits. I might do, I don't know. Why would you use 7mm? That's just cruel and unusual. Right, let's get rid of the drill because we're not going to need that. Hopefully. That's just gone under there. I'll be looking for that in a minute. Oh dear. Right, I'm going to be going down the back of there in a bit. Grab that. What I want to do is try and get down to those big fuses. And to do that, we need to strip some more of this side off. I really would not want to have to change one of those fuses. You generally expect everything here to be sort of field replaceable, or everything fuse wise certainly you'd expect to be field replaceable. And okay, that's all with that one. Bear in mind that to get to this you've got to have taken the driver's seat off. You're not going to get in through the front, and the Renault Master seats are notorious for getting them removed from the vehicle. Is that one now just spinning? Of course it is. They are held in with fairly reasonable sized Torx bolts. The back ones you can get out. If you've got a rattle gun, the back ones will come out in a few seconds. The front ones actually sit right up against the seat cushion, and the only way you can do it is a ball-headed Torx wrench, and you only get a tiny bit. Yeah, so as I said, you're going to struggle to remove them. That was, I believe, yes it was my screwdriver bit. So, I think the fact that they've managed to thread these into the aluminium is more a happy accident than anything else. I don't know that it's planned or. And this one I don't think is either. Right, okay, so they're out. Let's just buzz those off. I am going to go through the bottom of this and take all the nuts and washers out. It's just easier to be an animal and rattle everything out. There we go, another one out. So you can see the rectifiers here again. We have got 4 of them here. I'm not quite sure why you'd need 4. I bet we ain't going to be able to get in there. No, of course we're not. So, yeah, so you've got positive being used as an output, you've got an AC being used as an input. Same here, positive is your output, and then your ACs are the inputs for that circuit. So these 2 in the middle are almost certainly headlights. And I've just noticed they're also not crossheads. Because just be easy. You can see the light at the end of the tunnel. I'll admit that this is a cheap out video on the one that I had proposed to do. We have started putting the VDSL video together. Unfortunately, having got it all set up next to me, we had some problems getting a D-slam to talk. I've not got any of the diagnostic cables or anything handy, so we went for this instead. Oh, that one's actually a riv nut. Maybe I should have muted the computer. Annoyingly, sometimes recycling these rectifiers is not possible, or not using them for their original intended purpose. If I just pop these screws out of these, I will show you why. There we go. So that's a normal inner focus. That's a normal bridge rectifier. I think that's a 15 amp possibly, and you can see it's there, all the terminals are there. Same with that one, same with that one. But annoyingly they have a habit of, no, they haven't done it on this one. Normally you look at that, you've only got 3 terminals left, they'll cut the negative off, but they've just bent it back. So we will just grab that and pull it up. Focus. There. To be fair, it's not something I use a lot of anymore. With most power supplies now being switch mode, there's not quite the call for them anymore. So let's just have a look, see what we've got here. I think we'll be able to free this in a second and get this harness out of the way. Eject from my tools again. So I suppose possibly you could just stuff the harness. This has taken one of the almighty huge fuse holders with it and all the relays. So that is one harness. Let's just see, that also makes me think that there was never any intention for this to be serviceable. That screw, that relay cover is clipped on. Now that's what you call a fuse. That is a mega fuse, that's a 300 amp one. Oh. There we go. I'll do that 3 more times. quite get that one enough. So this is the comms battery feed, and as I said, you've got the comms battery feed comes in, goes off, and that jumpered straight up to one of those solenoids. But as you'll see when I pull this off in a second, the actual feed to all the comms kit is under here. It's that one there. So in theory, that could carry the full current from the battery in a fault condition. So no, I wouldn't say that's ideal. I would personally have put that on the other side of this fuse. There's probably a good reason that they've done it that way. And the cover on this, there it is. So yeah, you've got a provision here to cable lock this up, cable tie this on, and they had taken that. There we go. Look at the size of that battery cable. And what else does that free for us? Oh, now it's focusing on something that I don't want it to. So that frees the blue Anderson for us, which was ECU bus bar, so that's for the Genesis. We have another one free here. Ouch. That's the winch supplies. And then, oh, I think we might have another one we can free there. No, I'm not going to pick the entire harness out. So yeah, you could in theory do that as one lump, I guess. It's come out fairly easy. So that leaves us with these. Let's just cut these cable ties out. And we should then be able to get at the siren. It seems a bit silly that you've got to go to this level of death and devastation to actually get to the siren amp. Siren amps do fail. We don't have anything big enough to get them because I think we decided they were 12s. Oh, we do. That looks like, let me just have a look what we've got around here. That's one of those. The end box. Again, these are handling the full output of the battery though, so they're going to be fairly chunky. These are the charger inputs. Now, given that I'm keeping the charger, I will potentially keep this cable intact because it matches the one on the charger. Again, we've got another. These are quite often used for jump leads, incidentally. You'll occasionally see these on the front of 4x4s, and they're used for a permanent jump lead connection. And as I said, you can't make them to the wrong colour, as you can see. It's just not going to happen. Grab the blue one back. Same here. That won't connect. And it's not a case of they'll sort of go in and they won't connect. You actually cannot get those terminals anywhere near each other. Right, what have we got here? We've got another crosshead, and then we might actually be able to get to the siren. As I was saying, it seems a bit silly that you've got to go to this level of destruction to get to that siren. I don't think you would be able to get at that. You might possibly be able to get at it with a right angle type driver, but it doesn't seem like the best way of doing it. Right, let's rescue these. I had already been in here and removed the fuse for the inverter supply. The vehicle didn't actually appear to have an inverter. I wasn't aware that it had an inverter. Bear in mind that this vehicle's gone off to be scrapped. it makes me wonder if I may have missed the inverter in the truck. I honestly didn't see anywhere it could be, but the inverters generally fitted to ambulances are very heavy duty, generally around 3 kilowatt pure sine units, so they're not something you'd want to voluntarily lose. Not quite sure what that was. And these, as I say, like the other ones, they clip together. You can make them into bus bars, and bus bars make them into fuse boxes and stuff like that. There we go. That's everything for those. There's 3 covers there. So, last but not least, and that was a hex, wasn't it? That was a 3mm hex. Even with all that out of the way. Because all that actually needs, because they're slots, they're not holes, all that actually needs is just a quick tweak. And it'll lift off like that. And that's a fairly standard Whelen Alpha 12 siren. Probably the bit of the emergency service vehicles that you're most familiar with. Is it going to come out, or is it going to continue whiting out? And that's in really nice nick, that one as well. These quite frequently get quite beaten up. There's no date on it. Yes, there is. 8th of the 8th. This is 12 years old. That provides the sirens that you're familiar with hearing, along with the bullhorn as well. Quite frequently the bullhorn isn't wired up on these. And there we go. So I've now got a lot of nuts and bolts to tidy up and put away. I can't really see me actually ever using this again. The box is dead. I don't often have a need for random bits of aluminium. I'm not a machinist. Days I wish I were. We won't speculate on what all the grot in the bottom is. It's an ambulance. If you need to start asking questions about what the nasty stuff in the bottom of the seat boxes are, quite frankly, you don't need to be doing this job. Oh yes, riv nuts. Now if it will focus for me. Focus, thank you. This here is a riv nut, and as you can see it starts life as a little insert, and I don't think I've got any screws of the appropriate size. You press this through the panel, so you can possibly see down here, this is one here. You press it through the panel like that, and then the tool squeezes this down and compresses it behind the panel, locking it in, and then you've then got a threaded insert that you can thread nuts, bolts, well not nuts, but you can thread bolts, screws and things into. That's a really good way of doing it. Anyway, that's run on more than long enough. This now needs editing, and hopefully I'll get this uploaded soon and speak to you soon. Take care.